Okay, guys, here we go again. It's the second lesson of chapter 13. I hope the first lesson went okay. The first lesson was all about finding the limits, looking at a table, finding the limits, looking at a graph. The second lesson is a little more algebraic, where you're going to do some work, you're going to find the limit, and it's not that difficult, I don't think. Okay, hopefully you ran off those notes, and we're going to go. Here we go. All right, 13.2, finding limits using direct substitution and algebraic techniques that we will talk about in just a little bit. I'm going to break this up into video one here. Okay, so direct substitution, and let's go video two with algebraic techniques, okay? All right, let's move on. Second slide already. It says any continuous function should have a limit as, and then let's look at this. It says the limit of any function, and I said continuous, no breakups. The limit of f of x as x approaches a should equal the limit. Well, the limit, the one thing I didn't stress the other day was this. The limit has to be a real number. It can't be imaginary, and it's got to exist. All right. The number a down here, as you approach a also has to be a real number. This is in the definition. Okay, so if we look here, a constant function versus a linear versus a polynomial function. A polynomial is x to the first, x to the second, x to the third, and so on. But I just made it really simple, x squared. Let's look at these three functions, and we should know they are continuous. What's the limit of the function 5 as x approaches 3? Well, first let's draw 5. Now remember, this is your function. It's a constant function, 5, so it's 1, 2, 3, 4, 5 on the y-axis, and it is a horizontal line this way and this way. Okay, so if I said what's the limit of this function as x approaches 3, you'd go down here, 1, 2, 3. Okay, so as you approach 3 from the right side, so you get closer and closer to 3, your answers are 5, 5, 5. Okay, so this should be pretty obvious. Then we're approaching that number, that y value. As you come in from 3 on the left, you're getting what? 5, 5, 5, 5. So basically, it is, go back here, there it is, it's 5. So when you look at the limit of a constant function, if it says limit of 5, the answer is 5. If it would have said the limit of 10 as x approaches 3, it'd be 10. So these are very simple limit problems right here, okay? Okay, so the limit of, what's the limit of x as x approaches 3? Well, x, think of it as a slope of 1 plus y-intercept 0, right? So it's basically, it's your identity function. 1 goes in, 1 comes out. 2 goes in, 2 comes out, and so on. This is really small graph here. Okay, so here I go, up, 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 and down, down, down. There you go. Now, what's the limit as x approaches 3? Well, here's 1, here's 2, here's 3 again. If I come into 3 from the right side, you can see your answers are coming downhill, downhill. Here comes all your y values are approaching, looks like that y value right there. And as you come in from 3 on the left, you plug in a 1, a 2, and a 2.5, and so on, all your y values are approaching that point right there. And if you slide over, you should see the answer is 3. So the limit of x, the function x, as x approaches 3, turns out to be 3. So the identity function x, if you just put a 3 into x, you're going to get 3. If you said x is approaching 10, you'd put a 10 in, you'd get 10. Let's move over to the polynomials. I just made it simple, x squared. Well, an x squared function is, and I'm going to do this graph paper is so small, 1, 2, 3, I'm going to do that. I'm going to go by every 2 squares is 1 unit. Okay, and then on the y-axis, I am actually going to go by ones. So if you put in 0, you get 0. You put in 1, you get 1. You put in 2, you get 4. 1, 2. Okay, you put in 3, you get 9, and I'm thinking 9 is about here. So there's 9. So you get that parabola look. Okay. On the other side, I could just mirror it over like this. Okay. So what's the limit of x squared as x approaches 3? Well, if you come in from 3 on this side, you get these answers, right? Now you're going up the parabola, and you're heading towards that point. Come in from 3 on the right side, plug in a 5, 4, 3.5, 3.2, and so forth. You're getting all these points. And here it comes, as you get closer and closer to 3 with your x's, all you're going to get is a limit of, it looks like it's 9. Okay, and the point here is, the simple point is, when a function's continuous, as you approach 3, you can see already if you come straight up on the graph, hit the graph, come on over, you get your limit. But also, could you directly substitute it in? 3 goes in, x squared, well, 3 times 3 is 9. 3 goes into x, you get 3. 3 goes into, oh, there's nowhere to put this one. So because it's a constant function, it's just the constant value 5. Because every answer is 5. All right. So did you notice I can directly substitute it in and get an answer? Because that's what the lesson is about, direct substitution, okay? All right, so if we look at these functions, find the limit of each continuous function. Because you're talking continuous functions, an x cubed function could do, well, it could do many different things. I mean, it can go up, turn once, and turn twice, it can do this. So because it's continuous, when you approach 2 from the left, from the right, you should get some point on this graph. So can we just simply do this? Can we do direct substitution? Oops, that's a 3 minus 6 times 2 plus 1. 4 times 8 minus 12 plus 1. 32, take away 12 plus 1. That's 20 plus 1. 21. All right, if you graph this function and you approach 2 on the left, you approach 2 on the right with all your x values, get closer and closer to 2, you will approach the number 21. Okay, we don't really care that 2 goes in and you get 21. This is the limit. So as you put in a 1.9 and a 1.99 and a 1.999, you're approaching 21. We don't really care that the answer is 21. It's what you're approaching. That's the limit. Okay, exponential functions. You might not remember exponential, but exponential kind of had this look. That's exponential growth, and that's exponential decay. But notice these are continuous functions. Whoops, you couldn't see that, sorry. All right, so can we try it again? Just substitute in 3, raise it to the 2 squared plus 1, which is 3, raise it to the 4 plus 1, raise it to the 5th. 3 to the 5th is, 3 to the 5th, I don't know. Let me cheat a little bit. 3 to the 5th, I don't have my calculator near me, sorry. Let's try that again. All right, 3, raise it to the 5th is, there it is, 243. I must have knew there was a 3 in there. Okay, next up, a log function. Okay, well, log functions, you might not remember this either. Let's try it. Log functions were like this. They always crossed at 1, and they went this way downward and this way outward. Okay, but notice it's continuous. All right, so if you put the 2 in here, what happens? All right, so it'd be the log of 3 times 2 to the 5th plus 4, log of 3 times 32 plus 4, 96 plus 4, 100, the log of. Okay, so what's the log of 100? Well, that's going to be your limit. Well, you have to remember, log is, if you don't see a base, it's base 10. That's the common log. And remember how this works. The log of 100, base 10. The answer over here the answer is simply, if you don't remember, it's an exponent. Okay, so 10 to what power? Second. 10 squared is 100. Okay, so the limit of log of 3x to the fifth plus 5 as x approaches 2 would be 2. Okay, if you looked at the graph, you would see it approaches 2. Okay. Okay, next up. Okay, so I hope you're understanding that the big thing is continuous. If you have a continuous function, direct substitution is going to work. Okay, all right, move on down. This one's a little different, just slightly different. And how so? Well, if you look at this, hang on, I get this straightened out for you. Okay, so this is a square root function. Square root functions are a little different because yes, they are continuous. They go forever, one direction, but they start right at a point. And in this case, because you've got 2 minus x, it would be a reflection over the y-axis, and it's shifted 2 to the right, so then it takes off this way. That's not the important part, the graphing. What's important is you understand the limit as x approaches 1, as x approaches 3, as x approaches 2. Okay, so once again, let's just try direct substitution. What's the square root of 2 minus 1? Well, that's the square root of 1, which is 1. So it looks like the answer is 1. And here they're trying to show you that it really is. As you come into 1 from the left, and you come into the number 1 from the right, you go up the graph, you go down the graph. Okay, what are you approaching? This point right there. And if you slide over, what's the y value? 1. Aha, it worked. It's 1. Okay, so that one's not so bad. Okay, let's do the next one. Let's put in 3. Okay, if you get square root of 2 minus 3, you get square root of -1. You know the square root of -1 doesn't exist. It's not a real number. I suppose you could say it's the imaginary number I. Well, here's the problem. Your limit has to be a real number. You have to approach a number. You can't say I, so we say there is no limit. So does not exist. Okay, now if I look over here, let's just take a quick peek. As you approach 3, here's the number 3. You can't see it very well. Here's 1, here's 2. But as you approach 3, here I come from this direction. I'm approaching 3. Well, the second I get closer and closer to 3, if I look up or down, doesn't matter, I guess, you don't even get answers. There's no answers. You're not approaching, well, so far there's nothing to approach. If you come in from the right side, look up, look down, you're not getting any answers. So if you don't get any answers, you're not approaching any certain number. So that's why you say does not exist, mostly because you saw this. Your limit has to be real. All right, next, put in the 2, see what happens. Square root of 2 minus 2, square root of 0, answer 0. Is this the limit? Yes or no? Well, let's take a look. Here's 1, here's 2, here's 3, okay? As you approach 2 from the left, you do get this answer, this answer, this answer. So yes, you are getting answers. So it looks like you're approaching this y value 0. So 0 looks like it could be right. Well, I kind of gave it away. If you approach 2 from the right, are you approaching 0? Well, if you look up or down, doesn't matter again. You are not getting any solutions. No solutions from the right. And coming in from the left, you're approaching 0. But here's the deal. I had to skip a couple lessons here. And you have to understand this. For a limit to exist, you must approach the same y value from the left as you do from the right. And since from the left you're approaching 0, but from the right you're approaching nothing because you're not getting any answers, this limit does not exist, okay? Or you could simply say no limit. Okay, so cross that 0 out. It doesn't really work. Yes, you are approaching 0 from the left of 2, but from the right of 2, you're getting no solutions, so you're not approaching any number. The definition of a limit, if I would have been able to do the next section, I would have said limits only exist if you're approaching the number 2 from the left, you get 0. From the right, you get 0, but you're not from the right. Okay. Hopefully I made that one clear. Okay. All right. Last one. Let's take a look at this one, and then I'm going to shut the video off and say get started on your assignment. All right. Direct substitution. This is, to me, the first thing you do all the time. First thing. Okay, so if I did this right away, the limit of 2x plus 4, all of it over x squared minus 4. What is the limit as x approaches 0? If I put this in right here, and I put it in here, I'm going to end up with, I'm coming up here, guys, I'm going to end up with 2 times 0 plus 4, which is 4. And on the bottom, I'll end up with 0 squared minus 4 is negative 4. My answer is negative 1. So the answer, if I was in class, I'd slide that box over and get negative 1. So does the limit exist? Sure it does. Okay, so direct substitution is the first thing you do. And if I come down here, guys, and I just look at your graph, as x approaches 0, as you come in this way with x values, and you come in this way with x values, what are you approaching? Well, look, right here on the graph, you're approaching, looks like you're approaching this y value, which is negative 1. So yes, it does work. Okay, let's see if I can sneak it down a little closer. Okay. All right, let's try this one. Again, direct substitution right away. Put the 2 in here, you get 4 plus 4 over, put the 2 down here. You get 4, take away 4, which means you get 8 over 0. And 8 over 0 basically means, if you put it in here, guys, 8 over 0, it's undefined. And undefined just basically means the limit doesn't exist. Okay, now once again, look at the graph. As x approaches 2, here's 2 on the graph right here. As you approach 2 from the left, all your answers are getting smaller, and then they take off. As you get closer and closer to, it basically gives you what kind of y values? Negative infinity. As you come in to 2 on the right, where do your answers go? Basically, positive infinity. Are you approaching the same number? Not at all. The limit does not exist. Okay? So if direct substitution gives you an answer, go with it. If it gives you this, no limit exists. And now try this last one and see what happens. If you put a negative 2 in, you will get negative 4 plus 4. Okay? And you will get, in this case, 4 minus 4, which gives you 0 over 0. Okay, 0 over 0. They call this, there's a name for this, and it's under the box. It's called indeterminate. Okay, indeterminate means we're not getting an answer. It's not like the first one. We're not getting undefined. We're getting 0 over 0, so it's indeterminate. So in this case, the limit does exist, but you need to do some more work. And what's the some more work? Well, that is, guess what? That is the next video. So in the next video, I'll show you what to do. So let's take a quick peek at this one. X equals negative 2. Here's negative 2, 1, 2 right here. Okay, and if we come in from negative 2 on the left, that way, and we come into negative 2 from the right, well, we'd be coming up the curve this way. And it does look like we're catching up. It looks like we're approaching a number. But here's what really happens. I know you probably don't remember this from 4, 5, 6 months ago. But when we graphed these 4, 5, 6 months ago, what happened was there was a hole here. So that hole creates this funny answer, 0 over 0. But as you can see it on the graph, there is a limit. We're approaching a y value, I just don't know what it is. But we'll find out in video 2. Okay, so video 1 is done. I said after video 1, you could try these. You could just quit listening for a while and just go do your odds. And your odds, 11 through 21 odds and 35 to 45 odds. You can do it right now if you want, and then come back and listen to video 2. Okay, so direct substitution was the ticket in this one. Hopefully it made sense, and it shouldn't be that difficult, okay? All right, I'm done. Continue your assignment. Come back to video 2 in just a little bit.